Ciao Riccardo, ciao Arlette and Hilde, and all the others.
Well, hello everyone, welcome. We're gonna start our Aperitempo with a very special guest today. So I'll let yourself introduce your work.
So maybe I can introduce him. Maybe I can start introducing Federico. First thing I want to say thank you to be here with us and having with Aperitempo. And Federico was my professor at the University of Milan in my course, my degree in cognitive science. Was my professor of logic, but logic is only one of the subjects that actually he's studying. I invited him because there's a lot of discussion about science, and me too. More and more often, I find myself lost in what is science, or what science should be, or should be done, how should be done, and I have these feelings not only read the newspaper or watch television, especially in this particular moment where when you see television, there are many scientists talking in different and opposite ways sometimes. And actually I found myself a little bit lost, as I was saying. And it seems to me that science is sometimes like a religion where scientists are the highest priest. So when you talk about science or scientific data or fact, many times they talk about them as truth. That is not exactly what they are, or at least they are not static. Science should be something always ongoing. It's a process. It's not like a dogma. But I will leave the stage to Federico, and we can go deeper on this issue.
Okay, thanks, Riccardo, and thanks everyone for this invitation. I'm very happy to be here and have a discussion with you. As Riccardo was saying, I mean, I'm basically a philosopher of science, also working on the way scientists present their work to the society, because one of my research area is the relationship between science and the public, and so how science could work or should work into a democratic society, because apparently we have a clash. You have science where basically truths are not established through vote, I mean, according to the way science is presented. But on the other hand, you have a system where actually we make decisions, we take decisions through voting, right? And so the point is, when you have to vote on something where science can say something interesting or essential, how should you act, or how should you proceed? Should you preserve, let's say, scientific autonomy, or should you, put science under democratic scrutiny, let's say so. And so, I mean, this is something I studied since years, but few people paid attention to that, because they say, oh, look, I mean, this is science, don't bother us with this, and blah, blah, blah. And in Europe, I mean, in Italy, we had it, but also in other areas of Europe, we had the problems with the so-called vaccine hesitancy, for example. You know, people refusing to get their kids vaccinated, and the response of the scientific community was okay, these people don't understand. they're ignorant, they don't know science, they should stay silent and let the scientists do their work. And this was, let's say, accepted, even I wouldn't say acceptable, but this was accepted in the standard scenario. But now the COVID-19 gave us the opportunity to show that the situation is radically different from the way the scientific process is described. Because since the beginning of these so-called pandemics, we had a plethora of scientists, of different kind of scientists, claiming they have the way to explain what's happening. And so I think all of us experienced, not just on the media, but also on specialized journals, groups of scientists claiming, okay, this is a new model. With this new model, we explain this, this, and this. And then not just a few days later, but just a few hours later, on another journal, a different group of scientists proved something slightly different, till the point that there was another group of scientists proving something radically different. And so the point is, who should I trust? Because I mean, if science is there and scientists are just discovering the truth, why they're not able to discover the truth now? I mean, this is something that, of course, I mean, it's not correct to say, but this is what might appear when we look at the way science is presented. And so the point is that not just in terms of communication, but I would say also in the way scientist is done and pursued. These crises prompted, let's say, new perspectives on the scientific agenda, both from the way science is presented to the public to the way science is actually done. For example, now I think you might have heard that many scientists are asking for sharing data, sharing models, less competition and more cooperation. And this is something that will revolutionize science, not just in the practice of research, but in the way science is institutionalized. So will it change, for example, the ways science is financed and thought and organized at the institutional level? Well, it might be. Actually, some scientists, well, a lot of them are praying for this possibility. But of course, this will affect also economy, and not just the economy of science, but the economy itself. So actually, of course, I don't know. I mean, I'm not a wizard, so I don't know how the future will be. But definitely, this crisis has revealed some assumptions that were, had not been discussed before, or not enough, let's say so. And this is something with the academic community would do in the future. I mean, this is my opinion. I mean, since this aperitivo, it's actually an aperitivo, so I don't want to give a lecture. I would rather prefer having a discussion, of course, somehow coordinated, so not everybody speaks at the same time. But I mean, I would love to have your opinion, actually, because I think that most of you come from a different background, even if they are now part of a single institution, but I mean, most of you did study something different in the past. So I think it would be nice to have such a view, and maybe you can introduce yourself so we can all know each other a bit more. What do you think, Riccardo? Is it okay for you, and is it okay for everybody?
For me, it's definitely okay. So we can start a real conversation as in an
Yes, I just as you just said, I mean, I'm a philosopher of science. I was teaching logic to Riccardo, but actually I'm not doing research in logic itself. I mean, not anymore. And now I'm more interested in these aspects of the research. So also reasoning in the practice. So this is more or less one of my areas of research. I have another area of research that might be interesting for you, since your connection with food, the environment, and so on. Maybe we can discuss this later, since it's not the topic of today.
Because Federico is not just a philosopher, but is also, we can say, a scientist, is a member of scientific community, is some way an hybrid, but
yeah,
you are in the both sides.
Yeah, somehow, yes. I mean, I have been trained at the beginning as a philosopher, but then I studied biology and molecular biology later on. And so, I mean, I still consider myself a philosopher first, since I don't like to do experiments. I like to discuss experiments, but not to actually do them, because I think bench work is quite boring for me. But I like to discuss the results. But I actually work mainly with biologists at the moment. And I'm working on host microbiota interactions. So the way, I mean, I think you might be familiar with this notion, because now also it's quite trendy. So everybody speaks about microbiota, and of course I'm more interested, of course, in the conceptual and theoretical issues coming from these areas of research. But again, I mean, I don't want to focus on this now, or maybe later if you have some questions. But now I should stay on what we've planned. Okay.
If I can say just one thing,
Yeah.
we had an idea of doing one Aperitempo about Gaia, and including the holobiont concept and the microbiota. So we could organize one, and we would love if you could join.
Yes,
and,
definitely. I would love.
Perfect.
Yes. Thanks.
You're welcome. And well, I keep going, and I do also. I don't know if I have something meaningful to say about this, but something. What it looks to me is that during this pandemic, science has been put in the forefront of public attention. Everybody was okay. The scientific world, and this exposed both the strengths and the weaknesses of the scientific world. But I am noticing, I don't know if you share the idea, a trend in which, while at the beginning, this science around the pandemic was broadly accepted, now we see rising conspiracy theories of all kinds that innest themselves in sometime maybe in some weaknesses, or not really weaknesses, but sometimes there are expectations of the revealed truth, while science is a method mainly. So the conspiracy theories are nesting themselves into these gaps that the science cannot fill. I just wanted to ask you if you
I
see
agree
the
with
same
you
thing
on,
and
on
how
the on the
yes.
second part. I definitely agree with you because I mean the way science is presented by scientists, so not just by journalists, but I would say but many scientists, of course not all of them, but many scientists, is just presenting scientific results. So I go to the public and I show what I've produced. But very few normally is said about the ways science produces what produces. And these actually, cognitive psychology and cognitive sciences, I mean, Ricardo knows this very well, has, pursued research since 30 years at least, showing that in order to convince someone, the focus on the procedure is more important than the result. Because actually focusing on the procedure also helps people to understand, and understanding is a key component of trust. If people feel they do not fully understand, they trust less. And trust is a key factor in accepting science. Because of course, I mean, we normally say, look, you cannot know all what is done, you know, because you have an area of expertise. So I mean, for example, myself, I'm not expert in quantum physics, for example, you know. So when I talk to physicists and I talk to them, I mean, I trust them because I trust their expertise. So the point is that this trust is not just between lay people and experts, but it's also between two experts of a different field. So an oncologist and a geologist, let's say, would trust each other on the basis of, let's say, a tacit agreement, because they know more or less how science is done. And so the point is that, as you said, I mean, the method, it's important. I would say, I would use rather the plural, the methods. And so the point is that the one key factor to let people trust science, so produce the trust in science, is to engage them in the process of discovery. And this, of course, requires strong efforts, because it's not that easy, you know, to let common people share and participate to that. But this is something that is crucial. For example, in oncology, UK cancer research has seen an increase of effectiveness and support by the people once they have started to include patients and patients' associations in their meetings. Because of course, I mean, those meetings were not thought as if people started to tell scientists what to do or what kind of experiments you should do. But they brought to the scientist a perspective that for expert was not visible, which was the perspective of someone experiencing the disease. And this helped a lot, both sides. So on the one hand, helped patients and common people to understand the strength, as you said, but also the limits of scientific research. And so maybe let them understand that when scientists say, well, we are not sure here, this is not clear, blah, 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 this doesn't mean they're hiding something, you know. Uncertainty is part of the scientific research. But on the other hand, it helped a lot scientists themselves engaging with perspectives that they were blind to. and so both research and the public benefit for them. Of course, this requires a lot of efforts, and I mean, I know that other countries in Europe, I mean, share some of the problems with Italy on that. Some are more advanced, others less. But I would say this is a global problem. I wouldn't focus just on Italy. The problem in Italy, I would say, is that normally in the academia, people think that when an expert dedicates himself or herself to public understanding or to public engagement, is somehow diminishing his prestige and his or her role in the academia, and this is wrong. This is wrong because it's rather the opposite. And on the other hand, I mean, this promotes the fact that we have no criteria within the scientific community, within the academia, to evaluate and select those who engage themselves with the public. For example, I mean, maybe the non-Italian don't know him, but for example, in these months, I think all of us will remember Roberto Burioni on TV. And I mean, Burioni, of course, is a virologist, so is quite competent on the matter. But I mean, the fact that he became a science communicator is not part of any process, a certified process or controlled process. He just claimed, "Look, I know the topic. I can talk about it." And most of the time he's ignoring, for example, all this data coming from cognitive science, other stuff. So I mean, his approach, according to many experts, so it's not just me, you know, but many experts of the field, is most of the time detrimental rather than useful, because most of the time he helps in polarizing the debate rather than so he convinces people who are already convinced, and you know, let's say creates a vacuum between those who are convinced and those who are, you know, still uncertain, or, you know, on the other spectrum of the position. So I agree with you on that. Sorry, I'm quite verbose, so I tend to speak a lot, so you should stop me. Now, the last thing is that I think that conspiracies were present also at the beginning, but I would say that fear was that much that, let's say, counterbalanced this. But I mean, since also people from the scientific community, think about the French Nobel Prize Montagnier, went on TV claiming that the virus, for example, was a lab product. The situation changed a bit, because I mean, for example, imagine I go on TV and I talk to this guy. He can say, "Who are you? Miserable professor of University of Milan and Turin. I mean, who knows you? I'm a Nobel Prize. People should pay attention to me, not to you." And it would be difficult for me to counter such an argument. Even if it's appeal to authority, it works pretty well. So it's not that easy, you know.
Yeah, if I can jump in, when in my ignorance, I didn't know Luc Montagnier before. And so I saw him on television, and he was saying, yes, it's the virus of the HIV that they made. So then, well, I was very skeptic. I went to read about Luc Montagnier, and then I found out this incredible magical world of Luc Montagnier.
Yeah.
It's a scientist that invent his own scientific journal, in which the editorial board is Luc Montagnier, and then he submit articles that he wrote to his own journal. And then you have submitted 7 of February, accepted 9 of February, he read it and then accepted to himself. So once you understand all this, then you say, okay, now I understand.
Yes, but still, you're right, but still, he's a Nobel Prize. You know?
Yeah.
So, I mean, the scientific community, of course, I mean, counteracted, I mean, his claims. But again, it's not easy. If I go to my family, for example, that are not experts of the field, that they ask me, in fact, why shouldn't we trust Montagnier? I mean, he's a respected scientist. He's a Nobel Prize. Who are you? And this is very powerful. It's not easy to counter an argument like that, you know. So. And I think this is very. I will be very brief, and then I will leave you the word. I mean, this is something interesting because I mean we have been taught, and I mean when I was teaching to Riccardo, this is something I taught him, that appeal to authority is a fallacy. Okay, in science is a fallacy. But somehow we trust science precisely because we appeal to the authority, not of the single scientist, of course, but of the community. And so we trust science because we know that science is a community, is a sort of the jury, but a very special jury, with what I call the critical attitude. So we trust science because we believe that this collective wisdom is more capable than the single one to discriminate and certify what is truth, rather than, let's say, the single scientist, the single experiment, and so on. So this is also a tricky part, you know, because we normally say authority has no place in science. Yes and no, because it's true, the single scientist authority cannot overcome the standards of the community. But the standards of the community are part of a convention which is based on the authority of the collective. Of course, the collective of scientists themselves. So somehow there is a sort of paradox here, which is also very tricky to explain to the public. But this is something that I mean, this is something that pertains to the scientific work every day. I mean, science is based on uncertainty. Scientists are fighting, debating, struggling, even insulting each other all the time. But of course, I mean, even if when the struggle is harsh and fierce, they still, let's say, belong to this community with the unwritten rules and codes of practice that allow them, you know, to confront each other. While the representation of scientific debate on TV is just, you know, struggle, you know, people saying I'm right, you're wrong, and that's it. So this is also the problem. We have a misrepresentation of scientific debates, which are, of course, the most difficult part of the scientific work, and also the most difficult part to represent. Okay, sorry, I talk too much. Riccardo, you should stop me or do science like this or this.
No, it was really interesting. I may leave the word before to someone else. So if someone else want to say something, otherwise I can say a couple of reflections.
I think it was very interesting in the, oh, sorry, you want to say something, Nicolas? You go.
Okay, thank you. No, I've just been wondering and thinking about what Federico said. Because these days we are so used to instant gratification. So when this happens, when this whole pandemic happens, everyone wants to know the answer right away. But science takes time, takes patience. So the ones who are getting the the platform to spread knowledge are the ones who claim to have all the answers and who say nonsense, all the alternative facts. So scientists are left in the second, how do you say, behind, because they don't have all the answers. And also what he was saying about communicate what then digested to a different article expressed in a more understandable way, until it then becomes a short video where regular people can understand it. So it goes through a very long process of digesting it and translating it for the people to understand. And so yeah, it's basically that, like, there's not an ideal way of transmitting these new discoveries, and it takes time. So it gives space for people who don't know what they're talking about.
Yeah, also, yeah. Sorry, related to what you were just saying, now there is a problem of fast science, you know. So the fact that, you know, the community pushed the scientific community to work hard, for example, to produce the vaccine, blah, 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 therapies, models that will explain how the virus might spread and so on. And of course, I mean, scientists are working a lot, and this is done very fast, but we all know that science takes time. And so now a lot of people are saying, are we sure that, I mean, this speed is adequate for having reliable results? And of course, I mean, this might be a problem, because of course there is the need of having a fast response, but the way science is conceived, it's not working at this pace. So now there is a debate, for example, in epidemiology, whether we should trust more mathematical models with you know, strong predictive values on the top of randomized trials made in actual populations. And the point is that to build a model is not easier, but it's faster than run a randomized control trial. And so, but if this was just an academic debate, fine. But we have urgent needs coming from the real world. So this is not just epistemology, you know. It's really something we should tackle. And I mean, there is no answer at the moment to that.
Plus, I want to add, science is made on mistakes.
Oh yes, mainly on mistakes. So Hildweiser, you wanted to say? Yeah, did I pronounce it correct or not?
Hilde.
Hilde. But I saw your name is longer.
It's my last name.
It's a surname. Okay. Yeah. Sorry.
No problem. I thought it was very interesting in the beginning when you talked about like democracy and the non-voting of science, and it made me think of like how we trust in different countries our governments in different ways. And especially now in these times, different countries have their own strategies on how to handle the situation.
Yeah,
And especially here where I am in Sweden, we've made a very different decision.
I know.
But we've also talked about the fact that in the northern countries, the governmental trust is usually or generally very high.
Hi,
And
yes.
with culture in trusting our governments and trusting that other people or experts are making the right choices for us. Whereas in other countries, maybe the criticism is higher and you're not trusting your government in the same way, and also with corruption and other things. And I was wondering if it was somehow correlated also with science, that in a country where you have a higher level of trust in government, if you usually also trust science easier, because sometimes I feel here that, this is of course very personal, but that Sweden has a very high level of trust also in science, and when something new arrives, that's very fast accepted by the public population and not necessarily criticized in a way that I think maybe could have been useful.
Yeah, because I mean, the I don't remember the name of the Swedish epidemiologist who, of course, I mean, was in charge by the Swedish government to create the policy that you are now actually experiencing. I mean, he's of course a competent guy. He's not someone, you know, taken randomly. But again, I mean, science is not just facts, you know. It's about models and predictions and ways of explanation. So I mean, he adopted a view he, I think, genuinely thought it was the right way to do. But in the word, many of his colleagues are criticizing him, of course, not saying he's a moron, but saying maybe he's overconfident on this type of approach and he did not consider other approaches and so on. I mean, this is just a way to show that there are huge debates within the scientific community. And I mean, I cannot say that too much about anthropological features of European populations in trusting for example, in Italy, I mean, we all know that the low trust we have towards the government has historical roots. And I mean, I don't want to go into this discussion because it would be endless. It's true that for example, the so-called efficiency of the northern governments is well known to produce trust, but this of course might also have need to be connected with the fact that, for example, the population in the Nordic states, it's quite I mean, let's say not remarkable compared to the other countries. I mean, and this of course I mean, facilitates a bit the situation. On the other hand, I don't want to go also in this discussion that much, but I mean, if you know the famous French philosopher Michel Foucault, I mean, there is all this discussion of Foucault on the way the government, modern governments, used public health measures precisely to dominate the population. And one could say that probably, I mean, in a provocative way, one could say that the northern countries had achieved a so great level of let's say, administration of these issues, that the Foucaultian nightmare has been definitely realized. I mean, I'm of course, I'm not saying this. I'm saying that this might be a way to argument this. But I agree with you that trust does not depend just on what is said and on facts. it depends on many, a variety of circumstances. And of course, I mean, if one has to judge why, for example, in Sweden or in other Nordic countries, both the governments and the scientific community are trusted that much, sometimes too much, one could say, well, this is due to the fact that there is a particular situation, particular setting. There are variables that need to be taken into account, and all of these contribute to the fact that, on the average, the population accepts decisions taken by politics. So it's not just because Swedish scientists or politicians are just more capable of telling things. I mean, if you consider Germany, for example, I think in my view, Angela Merkel, to whom I mean, I don't like her very much in the political terms, but I have to say, I mean, she was brilliant in dealing with the pandemics, and also in the way she explained to the Germans how the pandemic works. And the point is that she was not successful just because she was so brilliant, also because she has a very strong scientific background. You know, she's a quantum chemist. But I mean, she was successful because the general condition of Germany in terms of the relationship between the public and the government have certain features. Nevertheless, they had troubles and discussions in Germany too, where actually the infection was not that bad as in Italy or France. On the other hand, you have the case of the UK, in which generally people tend to agree with, let's say, not just the government, but let's say certain standards and to the scientific community. But in the end, I mean, now the situation is, I think, pretty bad, and people are, starting to question the government more than ever. So I think that the context is quite important to evaluate these issues. Only one thing, I mean, the point is that also the production of scientific knowledge is somehow democratic in a sense, because I mean, I don't know whether you have experienced let's say you have passed through the experience of submitting a paper to a journal. In case you didn't, you don't know, but in case you did, you know perfectly what I'm talking about. I mean, you submit a paper, and then the paper will be published only if a community of your peer will evaluate positively and good enough to be published. So this explains very well a fact that scientific knowledge is not as such because it's produced through the scientific method, but because it relies on the agreement of a certain group of experts. Because if I conduct very nice experiments and I don't know, I prove that gravity somehow is different from what Newton discovered, but if I don't publish this data, this is not science. I can go everywhere saying, look, I proved this, look at my experiments, look. And people say, yes, but what is the control on that? Who looked at your work, say, and claimed and certified it was good enough? Nobody. So the scientific knowledge needs to have a sort of social baptism by the scientific community. Otherwise, it's not science. I can be the smartest and most brilliant scientist in the world, but if I don't publish on a journal that is considered a good journal, my research is useless. And so there is a sort of democratic procedure. Of course, I mean, not anyone has the right to vote, but still we vote.
I would add this way of producing science put a strong resistance against scientific revolution, of course, because the community of your peers will not accept something, some idea, some fact that
Exactly.
will create a revolution on what they're working on what they think is established already.
Definitely. So the scientific community is conservative. And I would say, in one sense, it's a good thing. Because, I mean, scientific claims need to show robustness against attempts to be refuted. So I think that in one sense, the fact that scientific community is conservative, so is, let's say, resistant to change, it's a positive thing on one hand. On the other hand, the risk is, you know, becoming dogmatic about the truth we all consider reliable at a given moment, you know. And this is something that, for example, Thomas Kuhn, the famous historian and philosopher of science, but former physicist, wrote in his marvelous masterpiece, you know, the Structure of Scientific Revolution, I mean, 1962, the first edition. And I mean, before we were discussing about, you know, the host microbiota interaction. I mean, think about the holobiont notion. I don't know if you are all familiar with that. You mentioned it, so I think that at least you are familiar with that. So the holobiont is something that is going against somehow the view biology had on organism, species, inheritance, symbiosis, and blah, blah, blah. Of course, I mean, so at the moment, the holobiont is part of science and part not. So part of the concept is accepted, but many scientists saying, well, it's more like a metaphor. We don't know how to investigate it. It's not exactly against symbiosis. It's a way to see symbiosis from a macro perspective, but it's still symbiosis. It's a good way to represent what's going on from, let's say, a mechanistic perspective, but it's not, for example, the holobiont, it's not an evolutionary unit of selection. So many evolutionary biologists are saying, okay, yes, it's cool that you mentioned that the fact that the organism have interactions with the microbes and so they form a network and so on. But look, evolution plays at certain level, and it's not the level of the holobiont. I mean, I was taking part to the discussion last week with the panel of experts all over discussing precisely this. So that there are scientists saying, look, the holobiont will help us to rewrite what we know about evolution, speciation, and so on, and others saying, no, not that far. And so in that case, we are facing a sort of transition. We are in a phase where science is let's say, not the normal phase, as Kuhn named it, and not even the revolutionary phase. We are in the phase of competing paradigms. And I mean, from my perspective, it's very nice to be to live in this phase, you know, because you see, you know, people struggling and trying, you know, to produce evidence to support their claims and blah blah blah. And we don't know the future. I mean, for example, people suggested that the holobiont perspective is the most useful tool to understand the pandemics, for example. So the whole notion of zoonosis, so the fact that the coronavirus was originated in one species, then jumped to another species, and eventually to humans, is more understandable if you have an ecological perspective on the way organisms interact to each other than the classical, let's say, pathological notion of what is a pathogen. But again, there is resistance. And I would say, even if I'm fully sympathetic with the holobiont and the ecological perspective, I like the fact that there are resistance, because I can produce my ideas, and these ideas will be tested and challenged by the critique of my colleagues. If this was too easy, I run the risk to say something which is not accurate. So I think that the strong of scientific effort lies precisely in this fact, that you are free to say whatever you want, but then you have to struggle a lot to prove it. And by prove it, I mean convincing your peers. And
I would definitely keep a Gaia holobiont discussion for another Aperitempo.
Yeah.
I just want to add one thing, and then I leave space to all the others. Sorry for speaking too much. What it was, now I forgot. What it was that I wanted to add? Well, I will come back.
No, okay, go Arlette, go, please.
I have a question, like regarding, okay, now you have this scientific committee that's already agreed on publishing something. How do you put all this massive information in another level, in a community level? Like, what would you think that will be the good way of doing it, or one good way of doing it? Because I think that these gaps are precisely filled with fake news.
Yes, well, one thing is that the scientific community is afraid that if science is presented as fallible and uncertain, people would distrust science. But this is not true. So I think we should be more open and transparent and honest in saying science is about uncertainty. It's a rational way to reduce uncertainty, but it's not a religion. So it's not a set of disciplines telling you what to do all the time. Most of the time, scientists would say, this is what we can propose to the level of knowledge we have. And we think, for our experience and the way science is done, that this might be better than other approaches. But we cannot be sure 100%. I mean, consider what Hilde was saying about Sweden. I mean, the epidemiologist who basically was the advisor of the Swedish government to not applying any lockdown was not a fool. Was a guy, talking about his experiences, saying, by considering the fact that Sweden is not heavily populated as other European countries, by considering the fact that in the Nordic countries, let's say, social or physical distancing is easier than in other countries, that let's say he explicitly mentioned this, that in Nordic countries the way people interact is let's say less warm than Mediterranean countries. We all laugh about that, but it's true, and it might be part of the success, so the point is that he didn't go to the public saying, look, this is science, you should trust, and that's it. He proposed a model, but of course he could be wrong. But the point is that only in the future we will know whether that was a smart move or a good move. For example, one of the reasons that motivated the decisions in Sweden was to create the famous herd immunity. For what I read, but I think things might change, this is something they did not achieve as they expected, because apparently the non-symptomatic did not develop the antibodies as all the models predicted. So because I mean, I don't know if you're familiar with infections, but the idea is that you pass through a disease, and if you got the disease, you develop antibodies for that disease. I mean, if you don't die, of course. And so the logic behind the herd immunity was, look, okay, if we let people got sick, but since the mortality of the disease is not that much, maybe, okay, that was very roughly and precisely, but the rationale of this. And so they expected that most of the people with no symptoms or few symptoms would have helped to create the so-called herd immunity. But apparently, the first data coming, so again, this is not solid truth. It's the first data coming, seems to suggest that the non-symptomatic, so people who got the disease but didn't show any symptoms or few symptoms, did not show the antibodies. So they still run the risk to get infected a second time. So we don't know that much on this virus. And so this is not to say that the Swedish epidemiologist was a fool. He had a rationale to implement that policy. And I think he was not alone. I mean, it was a scientific community, again, in Sweden, so academics discussed. They took this decision based also on the consideration I said. So social distancing is easier, some practices are easy, blah, blah, blah. And they made that choice. If that choice will turn out to be not the most effective one, you cannot blame scientists themselves, you know, because they made their evaluations, and it's called this is called inductive risk. So you make inductions. So you make a prediction and generalization on a limited amount of data, and then you flip a coin, let's say so. But I mean, this is not just random. This is not just betting. You know, it's making a bet with you know, by considering the evidence you have and weighting the evidence. For example, in the US, there is a famous epidemiologist, John Ioannidis, who said that the lockdown is a total mistake, because it's true that there is evidence supporting the fact that physical distancing is helping in you know, slowing down the virus, but we don't have evidence on the effects of the lockdown itself, on the psychology, on the economics, and so on. And so he said, this is not evidence-based policy, because we just randomly selected the evidence we wanted to implement the lockdown, because we took only health as, you know, source of evidence. But the world is complex. We don't just have, you know, health in terms of not having the virus. There is psychological health. And people after 3 months locked in their houses are going mad. This is something then you should take into account. So where is the evidence to do that? Nobody cared, because only epidemiologists and virologists, biologists, and clinicians were called, you know, to make this evaluation, not other experts. Even if those experts said, look, we should think about this and this and this. So the situation is quite complex. So I think, to answer to your question, scientists need to be more honest about how science works. And this maybe let people, you know, think that they are not like priests. So you don't go to priests, you don't go to scientists just to get answers, you know. But it's a long, so it's not something you do in a couple of days, you know. It's something it takes time. I hope again, I talked too much. Sorry, Riccardo.
Yeah, sorry, Ricardo, again, also from me. I just remembered, I have been reading Spillover of
Oh,
David
yes.
Quammen. That's a great book
Wonderful
that
book.
address all the zoonosis from very much from an ecological and epidemiological perspective. What I really liked of the book, and I think it fits very much with what we are speaking about, is that for every zoonosis that he described, he goes through the history of scientific findings on that disease. And especially, I would say, the HIV description, the chapter that goes through all the story of the findings of HIV, where it comes from, and all this. It and also the other chapter are great example of the difficulties, of the perils, of the lack of data that you can interpret in different ways.
Yeah.
That's a really difficult process, and you can see it in that book.
Can I say something on HIV, for example, since you mentioned? Okay, HIV at the beginning was considered by scientists just a minor problem because they thought, and also, I mean, the same thought that the vast majority of the population at that time, that was just a problem of the gay community. So, well, it's their problem. But, and this is something that experts agreed on, it was only because of the gay community started to fight and you know, against discrimination and saying that this is not what, I mean, this problem, okay, first it was not just of the gay community, and second, even if it could not be treated like that, that, you know, promoted within the scientific community the necessity of answering to these questions. And actually, it was through these movements from the people, not from the science, that the HIV became a global problem and a scientific problem and a clinical problem. So this is a case, a very important case, through which you understand that sometimes the answer and the perspective, the right perspective, doesn't come from the experts, but comes from those who are, you know, definitely stakeholders. Maybe they don't know the disease in the way the experts do. Nevertheless, they have, let's say, the right perspective to let the problem become what, I mean, or get the attention that deserved. If it was not for the gay community at the beginning of the 80s, HIV hadn't received the attention it deserved at that time. So that we have to be grateful to the gay community, especially in the US, the gay community that fought for that. Because if it was just for the experts, the situation would have been very, very different.
Can I just jump in?
Yeah.
It seems like this scientific world, it's ruled by this straight men mentality without any gender or equity perspective. And I think that's also a reason why it's not kind of well communicated with reality, perhaps.
Yeah, well, gender bias in science is huge, both in terms of positions. So I mean, the vast majority of you know, PIs and heads of departments and so on are males. This is a fact. And second, there is a gender bias in the way studies are conducted. Because, for example, when you study certain things as, for example, behavior, how could you know that, you know, being manipulated by a male or a female wouldn't change a thing in the lab rat, for example? Or, for example, you use, of course, females if you have, female rats, if you have to, study something that pertains to the anatomy of female rats. But sometimes you don't think that, studying the brain, for example, would affect the results. Could be that there is no difference, but if you assume it without any questioning, that might be a problem. Or, I mean, now that we were discussing about the microbiota, I mean, are there differences between females and males microbiota? And since the holobiome perspective is reshaping the notion of organism, maybe also our idea of sex and genders might be redefined. And so it's not true that we have just, I mean, it's not true also from social studies that we don't have just two sexes, of course. But I mean, in a more deep biological sense, we cannot reduce sexuality just to a couple of chromosomes. And this is not just because we are advanced and liberal and we like diversity and pluralism, which is something that, of course, I endorse. But I mean, so this is something that biology is telling us. So yes, it's full of biases related to gender, both from from those who make science and also from the objects and the results of science. And I would say not just towards what we call females, but also towards other sexes, and not just sexual orientations, like, I mean, biologically speaking. So yeah, it's a huge problem.
As you said before, science is very conservative, and there are many biases, and we just said a couple of them. There are many more, and there's a lot of discrimination inside science within the different fields of science, like social science, art science. So the social science are considered a little bit less science. So, but why? They should collaborate all together in order to tackle the problems that we are now living, especially the one we are now living, in order to find new models, new paradigms. And but science also a reflection of the society we live in. You said two words like the speed the science has to work on, and the production, the term production. So now we are facing a time where the academia is like a factory of knowledge production. And this is in psychology, the psychologists found the term publication bias. This is a big problem. So how well really works the sharing of the knowledge among peers and the validation of the knowledge among peers in this world of science?
Well, I will be very brief also because I don't want to annoy you, but thanks for this question because it's crucial. I mean, we didn't talk very much about how science is organized at the institutional level, which is something that, of course, has a huge impact on everything we said. But let's say that till 3 months ago, basically science was another branch of market capitalism. So producing, competing for production, getting more resources, that's it. So the famous publish or perish, it's an example of that. After these pandemics, some scientists started to, I mean, this is something that, of course, started way before the pandemics, but the pandemics gave the chance to restate the need of a change. And so the idea of having a cooperative model or cooperative system in which you don't compete with the others. I mean, you can compete in terms of, running experiments. So it's a good competition like in sports, but you don't compete with others to be the first because you want to be published so the others won't be published. You share your data with the others because your aim is to produce knowledge, not to, overcome your colleagues, which is actually what's happening, unfortunately. That's why, for example, I was very happy that a couple of years ago, PLOS Biology, which is an open journal, but with a very good reputation, published an editorial called On the Importance of Being Second, telling scientists, look, if you just have been scooped by someone else, we grant you to be published in the next 6 months if you can provide a solid pipeline. And this is something which is radically new, because I mean, if you want to submit a paper and just a week before someone else published something very similar, probably a good journal would say, well, this is not interesting very much, because it's already published. And this is crazy, because actually another paper claiming more or less the same thing would add strength to the scientific findings, a process that, for example, Karl Popper called corroboration. But this is not happening. And so I would say, for example, one thing, Riccardo, for the future would be, a radical change would be, to escape from the fierce dictatorship of scientific journals, which are the real authority in charge, deciding what is science from what is not. And this will take efforts, because it's not that easy. They're very powerful, very respected, and heavily financed. So it would take time. But I hope that all these movement about open science and open data will help in transforming science. On the other hand, it's true that we need to have some criteria to select which research fund and which not. So I agree that we need to have criteria for that. I would say these criteria shouldn't be based on a model which is basically mirroring the market system. I don't think it won't work. I think we will need models, but not this one.
Even the market is changing. Now we are talking about the sharing economy, right? So,
well, hopefully, but I'm not very optimistic on that.
At least right now we have Shiab. Not always working, but
yes,
there are other ways.
Yeah, but the point is that, so in the future, I mean, I don't want to, I mean, I'm very thankful for CHAB and LibGen for the things they provide. But I mean, I hope that in the future, I would hopefully not have to rely on Russian hackers to get what should be mine because I'm doing this job. So it's insane that, for example, I have subscription of the University of Turin that doesn't cover all the publications. And some of them I need to obtain through these methods, This is insane.
For us, we live in a really small university, so we don't have funds.
Yes, and this, of course, it's a matter of discrimination, because, of course, this system, of course, favors big university, especially private ones. So let's say the American universities, like the Ivy League, for example, or this kind, and so it's not fair. It's not fair.
It's not. Harvard have like something like $40 billion
Exactly.
in hedge funds.
Yes.
Funds
Yeah. Exactly.
invested in the market.
Yeah.
So
Exactly. So I'm fully agree with you. I'm not very optimistic about the changes in the market because I mean, I don't think that
neoliberalism will die soon.
I know. I think that the point is that okay, the pandemic is just the tip of the iceberg. People didn't realize that this was just let's say a preview of what might happen with the climate change issue. And so
I'm really sorry to interrupt this conversation because I think it could go on for hours and I would just sit here and listen and enjoy. But I think we might have to schedule more Aperitempo because we're already 20 minutes over time. And
yes,
want
sorry.
to take the time as much as possible. This has been incredibly interesting. And
I'm glad.
We're super, super grateful to have you both here. And just thank you so much.
It's grateful to have you. I mean, it was a very interesting discussion, and I'm sorry I talked too much, and many people maybe felt too shy to jump into the discussion. I hope it wasn't my fault.
Definitely not. Maybe if it's possible, if you're confident, you can share your email address and we'll share it.
Yes, I'll share it in the chat.
Please. So if anyone has a question, just feel free to write then.
Yes, and
but it's also hard to squeeze in this very broad, complex, super interesting topic into one little hour.
Yeah, we'll have, if you want, other. I mean, I would be happy also to listen to you. I mean, I don't want just to be the guest,
But you have been a wonderful guest. Thank you.
Thanks.
Yes, absolutely.
I'm grateful.
And next week, we're going to have the possibilities of risk with Cinzia Scafidi. And you're all welcome to join.
Thanks.
Federico, we'll include you in our email list.
Perfect.
And see
Thank
you
very
next
much.
week, same time. Thanks, everyone.